Thank you very much. Good morning, everybody. So my name is Harkeeret Singh. I'm the EMEA chair of the Green Grid, and I'm going to take you through the Green Grid's data center maturity model today. So just before we start getting into the model, I wanted to tell you a little bit about the Green Grid very quickly. So it's a not-for-profit international organization focused really on driving energy efficiency and sustainability in the whole computing ecosystem. And we develop metrics, promote standards, and really best practices that help users really improve the energy efficiency and sustainability of their computing environments. This next slide tells you a bit about the members that we have engaged. So the screen's big enough, hopefully you can see all of them. We have members from all over the world. We have members from the IT vendor community, from the M&E suppliers. We have end users. And we have a real mix across the world, and we're always welcoming new members as well. So if you're interested in participating, please come speak to me during the breaks, or Mark Monroe's here as well, who's the exec director, and just sort of have a chat with him as well, and he can tell you about some of the benefits of joining. So the data center maturity model, what is it? So the data center maturity model was created to really help users, to give them some directions around what they can do to improve the energy efficiency and sustainability across all the different aspects of the data center. It provides descriptions of what you can do by each data center area so that you can benchmark where you are today, how far you are from best practice, and where the future is going as well. So what we really want people to do and users to do is use the data center maturity model Equalizer, and we'll come into that in the presentation, to determine where they are today, determine the ongoing steps as to how they can improve the energy efficiency and sustainability of the data center, and use the higher levels of the model as part of their IT and data center strategy. Also, what we wanted to show people was when we hear about energy efficiency and sustainability, it tends to be a virtualization project and maybe a cooling upgrade. And what we wanted to show people was there's a lot more that can be done. So what this shows is it shows the journey across your whole data center and IT stack as to what you can do today and what you can do into the future. And also it allows you to benchmark to show your senior management how well you're doing. We see the data center maturity model being sort of the roadmap for the industry. So users push for it and ask for the things in the higher levels of the model. And manufacturers and vendors provide solutions that enable users to get there. Whether they're a data center in Hong Kong, Singapore, Mumbai, Dubai, New York, London. We want to see solutions that enable data centers to get there across the world, so it is location agnostic. So this is the data center maturity model, and I do commend the Google team for the big screen, so I'm sure you can read that from the back. Yes, I can see a few nods. No, I just wanted to show you what you're looking for. So when you go to the Green Grid's website, this is the document you look for. It's a PDF document at the moment. We are making it into an interactive tool so people can assess where they are. But this is the actual deliverable. It was created by a team from across the world, pretty much. We had input from the US, we had input from Europe, and we also had input from Japan as well. So when we actually created each content area, we balloted it across the whole Green Grid, so that allowed 400 people to comment on it. So it has got some, it's got quite a lot of content from a lot of different people. So this is where you can download it from on the Green Grid website. So it's thegreengrid.org. It's the third tab in, and what you're looking for is the full model. There is also a white paper. The white paper is really just a supporting document. I wanted it to be 2 pages. It ended up being 10. But there is some blank page in there as well, so it is pretty short. But the idea there is it just gives you some supporting information around some of the terms and definitions and how to use the model and a bit of background as well. So what does the maturity model cover? It covers the facility side of the house, but also the IT side as well. So we go into power, cooling, the management of the data center, and also other. Other was really a general bucket. So it picked up things like on the facility side, so things like building sustainability, lighting. It looked at building resilience according to your business need, those kind of things. On the IT side, it looks at compute, storage, and network. And again, there's another bucket which looks at procurement, looks at things like power supply efficiencies, which sit across the whole of the IT section. So that's really it covers both the facility side and the IT side. The reason we structured it in this way was because we found most enterprises are set up in this way. So a typical organization tends to have a power team, a cooling team, a compute team. So we structured it in this way so that you could take parts of the model and send it to an individual team within your organization, and so they can quickly identify where they are today, And you can use that as a way of setting objectives for them to improve over time. We also set it up in this way so that it was pertinent to the colo providers. So they can implement the facility side, and what we're seeing is they're handing the IT side to their customers and tenants to help them drive efficiency as well. So we're hopefully bridging that gap between the two. So what does the maturity model include? So in terms of scope, we covered energy efficiency, so the consumption of energy. We looked at energy supply as well, so low carbon generation is in there. We looked at utilization and effectiveness, so how well are you utilizing the assets that you have and have already installed. We started to touch upon the sustainability side, so it covers water with the WUE metric that the Green Grid has just released. We cover waste heat. There's also carbon in there, so the carbon usage effectiveness is the other metric we've just released as the Green Grid, and that's encapsulated in the model as well. We look at materials management, so start to look at e-waste and looking at life cycle approaches to actually looking at materials and management and waste as well. We then touch upon the building sustainability. So what we're trying to be is more holistic than the industry has been in the past. And as Zal said, absolutely, we then need to start looking up further into the stack. We also cover monitoring and metrics, which are included in the actual model. So down one side you have all the content areas, and across the top you have the different levels. So it goes from level 0 to level 5. So level 0 is a data center that has made minimal or no progress. A level 1 is a data center that's part best practice today. And level 2 is best practice today. So the vast majority of data centers today will be between level 0 and level 2. You know, when you assess yourself against the model, please don't expect to be level 5 because it's probably not going to happen. And if you're a level 0, don't worry about that. That's good. You know, there's opportunity in that space, so you know you can actually improve things. Don't feel too disheartened. What we've also done is we then defined what does level 5 look like. What does the 5-year view look like? Where do we want to be in 5 years' time? And then what we created was level 3 and 4, which became how do we get from best practice today to the 5-year vision. So what we see, the typical pathways we see for the data centers is we see the underperforming data center being at level 0 today. We see the typical data center, typical enterprise data center being at level 1, and we see the state-of-the-art data center being at level 2. Over the next 5 years, we see that the guys that are state-of-the-art are really driving towards level 5 in this model. And what we want to do is really push and encourage people to actually follow that green line as much as they can. And also, those that are leading is to share how you're doing it. Share what you're doing in the different locations across the world so others can learn from it as well. So I'm now going to start jumping into the individual sections within the maturity model. So the first section is power. I'm not going to go into each individual box, otherwise we'd be here all day. So I'm just going to tell you with different content areas. So please download the model from the Green Grid website and have a look at the detail. But I'm going to tell you the different categories we've covered in each section. So on the power section, we look at the critical power path efficiency. So we look at the power path from the building entrance to the IT load and how efficient that is. We don't talk about, it's also technology agnostic. We don't tell you whether you should use AC power, DC power, or anything like that. What we're most interested in is the level of efficiency. How you decide to then implement that is entirely up to you. It might be different in different countries. It might be different types of data centers in terms of sizing. That's entirely up to you. What we're most interested in is actually hitting the efficiency level. We then start talking about architecture. What can you do from an architecture perspective? Operations, so what can you do operationally once you've installed everything and running the site? And then we start touching upon low carbon generation. And what we've said here is it's really more for the future, this. We're looking at on-site, but also off-site low carbon generation. So on-site, people say to me today, Harkeeret, it's very difficult to do on-site renewable and low carbon generation. At best, what we're seeing solar panels to support some of the M&E plant room lighting or some of the office space, but nothing in terms of significant. So we will need some technology innovation, and that's what we need to actually push some of the higher levels of the model as well. From an off-site perspective, if you are using renewable power from an off-site perspective, we expect there to be some proof of additionality. So if you are buying, you're not just going to buy all the green power from the grid, but if you're buying from them, then the utility provider is now investing in additional green power so that you're actually moving the generation mix as well. Moving over to the cooling side, what we look at is the cooling contribution to your PUE, and what you'll see as you go up further up the levels, that should get smaller. We then look at RCI, which is a rack cooling index, which looks at how normalized the temperature is of the air going into your servers, and whether that's within the range that you want it to be. And that's if applicable, because that's only if using air cooling. We then move on to mechanical refrigerant cooling reduction, and we've been very specific with the words we've used here. You'll see in the model that what we're most interested in is reducing the amount of mechanical refrigerant cooling. How you do that is entirely up to you, whether you use air side economizers, water side, whether you open the doors and windows and use filters, whether you use liquid cooling to the rack, liquid cooling to the server, entirely up to you. What we're most interested in is reducing the amount of hours you're using mechanical and refrigerant cooling. And also we want to see some innovation. So, someone tell me how I can create a solution in Singapore, Mumbai or Dubai, which gets me to, using no mechanical refrigerant cooling for the whole year. So we want to really see some innovation, some of those warmer climates where it is a bit difficult today. We then touch upon environmental, so we're looking at set point ranges, and it aligns to some of the things that Zal said earlier. We then look at monitoring and control, and then from an operations perspective, it's all the good practices, and this is all sort of the blanket panels, the blocking the holes, make sure your tiles in the right place. We have really aligned to a lot of the good practices that are in the Code of Conduct. The Green Grid is an endorser of the Code of Conduct, and they do mirror each other. Moving over to the other side of the facility, we look at operational resilience. And what we mean by this is we're not talking about a tier standard. We're talking about making sure you standardize the way you map resilience so it's clear to see. We then talk about resilience versus need. And what this talks about is really making sure that you're building data centers according to your business need. Far too often people just build tier 3, tier 4 data centers because that's what everybody else is doing, or that's what the engineer wants to put on his resume. So what we're saying here is make sure you understand what your business needs and align your data center resilience according to that. We then talk about lighting, so all the efficiency, sensors, all that kind of good stuff. We then touch upon building and shell sustainability. So what we've said here as examples is we've got LEED in the US, we have BREEAM in the UK, but what we've said is you should align to your local building standard. So every country will have a different standard, but what we're asking you to do is align to that and actually achieve the higher levels according to that. We start touching upon M&E waste and also procurement. Moving to the management section of the facility, what you will see here is we're really talking about the monitoring and the metrics. So we're really asking about monitoring, we're asking about PUE. And what PUE says here is not just about measuring PUE, but it's actually doing something with the data. So actually, you'll see in the lower levels of PUE, what we're saying is gather the data and then use that to make business decisions. Use that to have a plan in place to make improvements. And what you'll see at level 5, and what we're looking for, and it's a challenge to some of the vendors out there who are providing tools which provide PUE now, which there are many of them, is we want a solution which takes in all the electricity data from all the different data centers, and actually using some clever algorithms actually gives you ideas of what you can do to improve your PUE. So we want to create a tool, or we want something that's automatic in terms of providing recommendations as to what you can do. Here's what you can do in your Singapore data center based on other data centers in the area. Here's what you can do, so actually looking at real value add. We then touch upon waste heat reuse. So if there's a real business benefit from using the waste heat, and we've seen things like heating the building next door, or heating the swimming pool. We've seen people taking cool water from under Milan and actually warming it in the data center and then using it to, in the winter, irrigate the local farms. So we are looking at what can you do to actually use that waste heat. There's also been, people said to me, Harks, my data center's in Miami, or it's in Mumbai, we have lots of heat. So what I would say is use that if it's applicable, but even in some of those warmer areas in the world, it does get cold at night in the desert, so there may still be a useful need for it. We then touch upon CUE, and this looks at the carbon emissions of your data center. And as you go up the levels, what it starts to look at is not just your scope 1 and 2, according to the greenhouse gas protocol, but it starts looking at scope 3. Firstly, what's in your control, so things like employee travel and business travel. And then it starts looking at your supply chain and also how your product is used by your customers, so you're looking at it from a wider perspective. We also touch upon the water use to effectiveness, both the site, WUE, and also source. And then what we've put in here is XUE, or additional metrics. And what we're saying here is we understand businesses will have their own business metrics. So you can plug that into the maturity model and use this as a way of measuring how mature you are as using those metrics as well. So moving over to the IT side, So on the IT side, and from a compute perspective, we look at utilization, so managing utilization. And what you'll see in the model is, as you go further up, we're looking at increasing the percentage, the average monthly percentage. We look at workload management. How can you reduce the amount of workload within your data center? We look at what you can do operationally. A lot of people say the green grid, so there's around 10%. The Uptime Institute say it's around 15%. The amount of servers within your data center estate that you can take out without any business impact. We then look at power management. So what can you do from a power management perspective? And what we've got here is we have said as long as it's applicable to your business type. So going through the different power management states, there is a latency impact. So for the real-time systems, it might not be feasible. But for your HR application, if it takes an extra half a second to load, it's not too painful, to be honest. So please implement it where possible. The other thing we've done here as well, this is not just for users, but also for vendors. The challenge we've put in here for vendors is providers power management that has no business impact. So we can all use power management, and power will scale with the actual workload of the server. We then start touching upon the server populations and tech refresh and when that makes sense and having the right models in place. And what you'll find is on the IT side, it's a very similar structure. So you'll see storage looks at, again, workload. So how do you reduce the amount of storage you have? So things like deduplication. We then look at architecture, which looks at tiering of storage. We look at what you can do operationally. And what we mean by this is, a lot of people do server decommissioning programs and get rid of those sort of 10% of servers that are doing nothing. But what they forget to do is to tell the storage guys and the network guys that they've just got rid of all these servers. So what they can do is, if you gave them a list of servers, they can either they can decommission it if there's a big number, or they'll repurpose the storage. So making sure they know you need to do those things as well. From a technology perspective, this is really for the technology providers and the storage vendors. SNIA did an exercise where they looked at the power consumption of a storage unit, and what they found was even at idle it consumes 80 to 90% of the power as it does when it's running at 100%. So we really want to push the storage manufacturers now to make the power consumption more scalable with utilization, and also for them to implement things like low power management states, which they don't have in storage units today. We then also look at provisioning, and really aligning provisioning to what's actually needed rather than what people ask for. The network side of the house, very similar. We look at network utilization. We look at what you can do in terms of reducing workload, what you can do operationally. Again, assessing technology and looking at how that can become more efficient and what you should ask for as a user. Looking at base performance of the network and also provisioning. So the final section is the other section of IT. And what we look at here is generally utilization across all the different aspects of the IT. We look at IT sizing, making sure you're sizing it according to what's actually needed. Then we look at internal power supplies, and this really covers compute, storage, and network. And what we're looking for here, what you'll see in the model, is we're looking for an increasing percentage of your data center IT equipment having power supplies aligned to the Climate Savers Computing Initiative. And as you might know, is it also has a sort of a bronze, silver, platinum, gold platinum ranking system. So what we're looking for also is more of them coming from a higher standard as you go up the model. The next two really go hand in hand. So service catalogs and incentivizing change for efficient behavior. And it's a bit of a mouthful, but what we're really talking about there is things like cost awareness and chargeback. By having a service catalog in place and having something like chargeback in place, what you'll find is people actually think about what they ask for, rather than just when things are free, they tend to ask for a lot more. So what you're doing is right-sizing that demand side as well. We then touch upon e-waste, and we have aligned to local standards. So we have things like the WEEE directive, and we have reduction of hazardous substances. And we're really talking about having an e-waste policy in place and a strategy in place, and actually you'll see that increases as you go up the levels. And then the final section on the IT other side looks at procurement. And what we've aligned to here is things like Energy Star for enterprise servers. So we're asking for people that are more mature on this model to be asking those harder questions and really getting those servers and IT equipment, which is a lot more efficient. So that's what you're looking for, guys. Go download it and have a look through it. It's a pretty big document. We know it's pretty big. We did sort of put all our ideas on a piece of paper and thought we'll prioritize it at the end. But then when we came to prioritizing it, there was just so much good stuff there, we didn't take anything out. So that's why it's so big. In terms of relationships and interdependencies, there are some in the model, and these are outlined in the white paper. So what we found is we talk about increase in temperature, and we can't really increase temperature without risk unless we do all the airflow management things as well. So what we're saying is do all the airflow management things and then increase temperature. Level 5 on the no mechanical refrigerant cooling is 100% of annual hours, so 8,760 hours. And warmer climates will need IT equipment that can probably be operated at higher temperatures, but also we'll need to see some cooling innovation. The last interdependency here is widening temperature and humidity parameters is likely to be more relevant for newer sites. As Zal said, with the fan power curves, you can make sure all the IT equipment is procured in alignment with the same standards and also minimizing the impact of fan power changes. The last thing I wanted to show you before I stop is this is the data center maturity model Equalizer. And what this allows you to do is map where you are today, so the green is achieved. And what this shows you quite quickly, graphically, is where you're doing well and not so well. So if you're looking at, you've got a limited amount of budget, where best to spend it, you might want to spend it where there's level zeros across your facility and IT. The orange is your organizational target, and that will be very different depending on whether the data center is strategic or not, depending on whether it's in Singapore, Mumbai versus London or the Scottish countryside, depending on whether it's in the countryside versus a mid-floor in a high-rise in Manhattan. So depending on your business constraints, your financial constraints, your site constraints, you decide how far you want to go on the model. And the black box here just tells you what's the maximum. So you won't always go for the maximum, but you define yourself how far you want to go. And what we've seen is people have looked at it and said, this is great, I'll send it to my data center manager, ask him to map where we are today, ask him how far he can go with a little bit of money, and then ask him how far he can go with a lot of money, and then use that as a way of setting objectives and driving awareness also within the data centers for those folk that live in buildings with no windows and don't get out very much. And so what we see this being is really the roadmap for the industry. We see users pushing for the higher levels of the model. We see vendors and manufacturers providing solutions which enable users to get there. So what I would say is, benchmark your data center today, find out, where you are, see how you compare against best practice, which is level 2, and then you can hopefully identify some of the steps and some of the ideas around what you can do going forward, and then really use the higher levels to really push your data center IT strategy. And what we're seeing is, send out the model with your RFPs for your data center and ask your data center designers to get you as far to the right as possible. And if you need to do a bit of innovation and you need to do things differently from an operational perspective, tell them to come back to you and tell you. Far too often what we see is people design data centers based on the same design they had last time. They scribble off the AT&T name, write Thomson Reuters on there, so that's $250,000, please, because they're not worried about how much it costs operationally because they'll be moving on to the next project. So, use this as a way to really push innovation. That's what we hope it will do. And also it provides a view for your senior management as to what is the journey for improving energy efficiency and sustainability. Thank you. Sorry, I'm over a bit.
Thank you very much, Harks. We have a few minutes for questions before we move on to the break.
Answered all of them. Brilliant. Well, I'm here for the rest of the day as well, so if you do want to talk about it and go into any more detail, just catch me outside or throughout the day.
Oh, there is one over there.
Oh, there is one.
Jim? Yeah, please take the mic so we can record it.
Right. Velo Everett from Toronto. We're also a contributing member to the Green Grid. I'm just wondering for the audience, we spent a lot of time concentrating on free cooling, but for us the energy reuse is really the largest area now that we've got the PUE down to 1.15 or 1.07. It's concentrating on the other side of it, and obviously if you could maybe explain for the audience some of the details on measuring PU, because energy reuse doesn't necessarily, I think, improve PU according to the calculations, and what some of the things that you're seeing are that do that.
No, it's a good question. I mean, you make a good point. I think people are now feeling they've cracked the PUE piece, and that's what the model does. It starts to look at the other pieces. In terms of PUE versus the waste heat reuse, the Green Grid have created a white paper on the ERE metric, which looks at waste heat. But we're very clear that any kind of waste heat reuse is not calculated as part of your PUE metric. So you can download both papers from the Green Grid's website. The PUE metric now has been globally harmonized, and we're working with the EU and working with the US government agencies and also Japan. So it's a lot more stringent now, there's a lot more detail behind it as well, so you can get all that data from the Green Grid website. Any
More questions? Yes, one over here.
Thanks. Just a point of clarification, Harks. Coming back to something Zal said in his presentation before, you just said we've kind of got the PUE piece cracked now, and people talk about energy reuse. The reality of the situation is that we should carry on talking about PUE, because at the moment the average PUE is still way above 1.8 average.
Yeah.
And very few people have cracked the PUE. We all know how to do it. That's not quite the point, though, is it? The point is that we should carry on. You should carry on banging the green grid drum, and Zal and the specialist data centre group of the BCS should carry on. You know, and Don of Ashray says, you know, I'm really bored with talking about elevating temperatures, but the thing is, we shouldn't get bored about it because no one's doing it yet.
No, it's a good point. You do need to carry on doing it. I mean, if you looked at PUE 5 years ago, and you look at the data centers 5 years ago, they were a lot higher than they are today, and part load efficiency has improved significantly as well. So what I mean by we've cracked it, that is actually a quote from somebody in this industry. But a lot of people feel as though they know how to get to a decent PUE. Obviously, if they've got data centers 10, 15, 20 years old, there'll be a refresh, or when they change it, that'll be different. But yeah, absolutely, you need to continually manage that and actually keep on top of it, absolutely.
Any more question? Well, in this case, thank you very much, Arks.